Nadine.
Claire.
And we are attending here from iExperience, which is a bootcamp based in Cape Town. And we're hoping to find out how AI is going to change the business world in the next few years.
Ernst Herzog. I'm an angel investor, so trying to learn a bit more about AI and what's relevant and how that will affect investment decisions. So yeah, quite excited to learn a bit tonight.
Alex Conway. I'm a stats machine learning master's student at UCT and working on a spatial machine learning startup.
Hi, my name is Raymond Ellis. I'm a senior data scientist with Data Profit. We're machine learning specialists in Cape Town, and we are here to just see what people have to say about AI.
My name is William Mapham, founder of Bula Mobile. I'm here to see how AI can be applied to health data in the South African context.
My name is Mpendulon Lovu. I work at Global Kinetic. I'm interested in machine learning, so I came to see how artificial intelligence I can implement it in my work.
Hi, I'm Nick. I'm from Gmo World. I'm a decision/data scientist, and I'm here to find out more about what other people in Cape Town are thinking and the kind of research that's going on.
Hi, I'm Aminio. I'm working at Groupon, South Africa. What I hope to learn from this presentation is basically to broaden my view of AI and its effects in the future.
Good evening, everyone, and welcome to another Silicon Cape Tech Talk. It's great to have such a good turnout and to see lots of new faces here. I think, Jacques, that's also thanks to you for spreading the word to new communities. So welcome if this is your first Silicon Cape Tech Talk. Just to remind you to tweet, please, and the hashtag is SC Tech Talks. Then just a few announcements. We have designed this panel discussion as quite a broad topic on artificial intelligence. And we have a great panel lined up for you tonight. But if you would like additional topics to be explored in depth or would like to suggest new topics, please just use the hashtag and direct your comments at Twitter. And then we can follow up and do more detailed tech talks on more specific topics, if that makes any sense. And then just another reminder, we've got a few community announcements. The first one is from Workshop 17, and then Jacques is going to talk to us and do a short presentation there before we start the panel discussion. The other thing is it is Women's Month in August, and we would like to showcase as many female founders as possible of tech companies. So if you are a female founder or you think we should be profiling someone who is a female founder, please email engage@siliconcape.com, and we will very gladly profile them because there are a number of women-focused events during the month of August, including Startup Grind as well as the Silicon Cape Tech Talks. And Wes, I'm handing over to you.
Thanks, Alex. How's it, guys? For those of you who don't know me, my name's Wesley. I lead the team here at Workshop 17, and I'm just going to take about 2 minutes of your time. The success of the last year has actually empowered us to expand Workshop 17's offerings. So those of you who don't know, we've just launched a brand new space directly across the road. The focus being around our development businesses and our partners. Codex and MLab have officially moved across the road just to the back and left there, which is quite exciting because it gives an opportunity for our community to grow. And we are opening up applications for new members at Workshop 17. And we really like a few of you guys to apply. We're specifically focusing around technology in finance, health, travel and education. So if you are looking for office space, whether it be flexible offices, hot desking, or dedicated office space, please get in touch with us. You can either drop me a mail at wesley@workshop17 or just at info@workshop17. And we'd really like to see you here collaborating with some of our other businesses. And hopefully we can grow the community and continue to see the ecosystem in the Western Cape grow as well. Over to you.
Thank you, Wesley. Good evening. My name is Jacques Ludik. I see some familiar faces from the Machine Intelligence Institute of Africa, MIIA. I see Senfree. Yep, welcome. And I see a lot of people that I don't know as well, so welcome to everyone. Alex has asked me to give a short introduction to MIIA, Machine Intelligence Institute of Africa. And I was just thinking, I'm going to do that. That's going to be probably 5 minutes. I don't want to talk too much about it, but pretty excited about that. But I want to frame that within a bit of a broader framework, talking about education, entrepreneurship, ecosystem. And the slides will actually show you where I think it fits in. I'm also going to discuss some ideas about smart technology, software COE, that I want to propose to universities as well, which I think it's absolutely critical and needed. But I want to frame this within the, I don't know, who have heard about the fourth industrial revolution? Okay, so it looks like about 50% or less of the people. You will probably see some books, especially the World Economic Forum has talked quite a bit about that, and there's quite a bit of, there's a book even out by their president talking about that. In Germany, they talk about Industry 4.0. I sold my company to General Electric. General Electric talks about, by the way, it's also an AI company. I'll talk more about that also in a panel discussion. I think there's a lot of lessons and things to share. But General Electric talks about the industrial internet. So, but it's, I'm going to talk about those. When they talk about that, they all talk about the fourth industrial revolution. So, and in this talk, I'm talking, the term that I'm using is smart technology era. So, I'm actually writing a book right now, trying to commit myself to finish that, on shaping our future in the smart technology era. And what's the implications for us here in Africa as well? So my big concern is that Africa will be left behind if we don't latch on and utilize the technologies that's offered by the fourth industrial revolution. It's almost like a two-edged sword. It is a way to leapfrog, but it's also giving obviously other economies, other developed markets the opportunity to really move at an incredibly fast pace. As we've seen with Uber, Airbnb, and all these kind of companies that's disrupting industries. So it's quite urgent. So we need to do something about this. So that's what this is about. So I've got a few slides talking about that. So the fourth industrial revolution, I'd like to maybe read that first sentence there. We stand on the brink of a technology revolution that will fundamentally alter the way we live, work, and relate to one another. A key technology that's going to help enable that is artificial intelligence. Artificial intelligence is going to play a hugely important role. Also, if you think about the scale, the scope, the complexity, the systems-wide impact, industry-wide impact, it's going to be huge, and you can already see it making an impact. So what is the definition? So we talk about the fourth industrial revolution. Few people don't, so you probably know about the first, the second, and the third. The first, second, and third is all about mechanizing production, then creating mass production. That was the second revolution. Then the digital revolution was all about automating production, and we're now entering into smart automation. And it's not only that, it's actually fusing of technologies, and it's a multiple technologies of which artificial intelligence is one. So if you look at the definition there, new technologies that are fusing the physical, the digital, and the biological worlds, impacting all disciplines, economies, and industries, and even challenging ideas about what it means to be human. Especially when you talk about augmented reality, virtual reality, talk about human brain, computer interfaces, those type of things. It's getting very interesting. So there's a lot of ethical things that one needs to discuss, etc. So I thought about, I've got a certain vision, specifically for Africa, there's so many things that we need to address, so many different problems. And with MIIA, on the MIIA website, it's machineintelligenceafrica.org. You will see one of the pages there talks about the problems that we have in Africa, and also some solutions and so forth. More from a machine intelligence perspective, data science perspective. But if you think about what we need here, we need visionary leadership, we need execution, and specifically what we need is a proper educational entrepreneurship ecosystem that capitalizes on the fourth industrial revolution technologies, and we need to use that. So first of all, everyone should have affordable access to digital world, and currently 60% of the world population is offline, don't have access, so which is a huge problem. Obviously, we're addressing it. If you think about what's happening in Africa with feature phones and also the growth of smartphones, which is just tremendous. I think another thing, if you think about the skills that's necessary, we talk about technology that's tremendously disruptive. We talk about complex environments. So it's not just your foundational literacies. We talk about people need to be able to deal with complex environments, need to be able to deal with changing environments. So, and there are 16 skills that you need, and it's extremely important that we teach on a primary, secondary education. We've got to make sure on a tertiary education that people do have those skills, because it's super important. Yeah, I've mentioned the leapfrog. We've got problems. We've got deadlock, education, healthcare, energy, agriculture, unemployment, on competitiveness. And I think with these technologies, we do have an opportunity to do something about it. So the next few slides will be about the smart technology. It's just that's more a proposal. MIIA is more what we're actually doing, so I'll be talking a bit more about that. So with the smart technology CUEs, I want to, as I've mentioned, have a discussion with universities talking about technology, entrepreneurship, accelerator. We need this. And I've got a few things, just initial proposals of what I think it should look like. So I'll discuss that in the next slide. But the Machine Intelligence Institute of Africa was the whole idea there was just, as part of an ecosystem, you need to have the community represented. There's people that want to do stuff. They want to build businesses. They want to be entrepreneurs. They want to use artificial intelligence. If you look at this, the people just here, people interested in AI and its applications and stuff. So it is a vehicle for people to just collaborate, come together, chat. You never know. You might meet people there that you want to start up companies with, you want to work with. Alex Conway, I've got a discussion with these guys as well. They've got a very interesting project, and we're going to talk more about. That's a great use case for me. You never know what's going to happen because of that. So MIIA is really a place where you can, we do communicate on Slack and so forth. So I've got a few slides just talking a little bit about that. But the focus here is machine intelligence and data science, research and applications to help transform Africa. And then finally, I think with fourth industrial revolution technologies, we can do a lot in terms of smart education. If you think about just personalized learning, cognitive computing, that's all. AI is going to make a tremendous impact there. If you look at IBM Watson is being used for cognitive computing. Well, there's some other platforms as well. And they do have some very interesting solutions. But there's many other companies as well. So I think it's hugely important. Secure collaborative collaboration platform. I think also with universities, they're probably not in the business that they think they are now, if you think about the disruption, because education will be disrupted. So you need to think about, how am I going to utilize this network of people that we've got? What about my alumni network? So you want to tap into that, because if you think about, it's not this one-time learning anymore. We talk about lifelong learning and life-wide learning, those type of things. So there's huge opportunities for new business models. And you think about blockchain, for instance, secure digital certification. Universities know how to do certification, but they need to look at these type of things. So there's a bunch of stuff. And then finally, government. I think we all want efficient, transparent, agile tech-empowered government and the public sector. And I think we can create decentralized governance and regulatory services using, say, blockchain technology. It's coming anyway. And we need to do something about that. So this is another example. So smart technology CUE. I'm going to be quick with the rest of it. We can talk about this afterwards, maybe in a panel discussion with these people interested to know more about this. This is more specific idea. I think there's three important components. The first one is just the learning and research. So what we need is technology entrepreneurship master's program. We need a machine intelligence and data science master's program as well. And if you think about the prerequisites of innovation, collaboration is one. The other one is interdisciplinary work and research. So, and there's a lot of innovation and breakthroughs that's happening at the cusp of those disciplines. And we need, and unfortunately, if you look at universities, it's really focused on, there's a lot of in-silo, in-departmental type of innovation that's happening. So, that's why they try to make breakthroughs. And I think we need to break that up. And I think with this smart technology CUE, you can try to do something like that. So on the learning and research, we want to also work on truly breakthrough. It's not just about papers and things you produce. It needs to be stuff that's really making a difference. And then the startup incubation, the whole idea there is to actually flip it a little bit around. Normally we talk about startup labs where you're looking for people that's coming with interesting ideas, but we know what the problems are. We know the technologies. So if you flip it around, say in this technology CUE, we are thinking about, we're actually developing business plans to address the problems in Africa, utilizing these technologies, and then you can say, smart education, smart agriculture, smart healthcare, what does it mean? So you actually develop it from there. You can actually just incubate it, and then it can grow from there. So I've got some ideas in that regard as well. And then collaboration. I've talked about collaboration already. So this is just from a university perspective. At the top you see university faculties, departments, working in silos and so forth. And the whole idea is that you've got them interacting with the smart technology CUE. Some of the universities do have technology transfer companies and launch labs and so forth, but you need a really focused effort in generating companies and doing proper research and getting people upskilled in what they need to have. Then, if you think about more broadly, it will be really great if you've got smart technology CUEs at every university or at a number of universities that can do it. And then they are collaborating with other components, other entities within the ecosystem. So government, regional technical hubs like Silicon Cape, for instance. You've got MIIA as a community organization. There's technology providers, VC, startup incubators, etc. So you definitely want to get that going. And then you can think more broadly. You can set it up in different countries. From a MIIA perspective, we've got one of the guys from Professor McSherry. He is heading up a World Bank-funded Center of Excellence for Data Science in Rwanda, for instance. So there's initiatives like that. So you can hook up with that and start collaborate. So there's lots of opportunities. In terms of, I want to get into the second part, and it will be very short, a few minutes. So I've talked about the Smart Technology CUE, the Machine Intelligence Institute of Africa. What about the collaboration? So we've got the community here. Currently it's about 200 plus members and followers, more members than followers, but lots of people that's interested and really want to do something in Africa, making a difference using these technologies. But if you've got a Smart Technology COE, you can start saying, okay, we get community involvement to help shape it. We do have programs that people can participate in to skill them up, to make sure they do have all the necessary understanding of entrepreneurship and what it means to actually operate in the fourth industrial revolution. Maybe join the COE incubated companies, join the university and ecosystem collaboration platform, those type of things. And then from a MIIA perspective, and the next few slides will be all about that. And it's, as I've already mentioned, the community interaction, participation in projects, and so forth. And so I've already introduced MIIA now, so I just want to, I've already mentioned we are 200 plus members. There's a bunch of partners already, and we've got, as I've mentioned, we've got Insights, Send-Free and Insights to Impact represented here. And I believe we're looking at some collaboration stuff. I know there's some stuff in setup, so I'm looking forward to that. So that's going to be awesome. I've been working a little bit with Get Smarter. They're also a pretty interesting company as well, presenting all sorts of courses. Yeah, so, okay, so, done. So I'm going to, all of this stuff is on the website, machineintelligenceafrica.org. So if you want to even participate, how to participate, everything is listed there as well. So, and I can make the slides available afterwards as well. So I just wanted to make you aware of that. There's also this community chat on MIIA, so people are collaborating and chatting and sharing stuff. Alex, is you? And I'll probably end with this slide. I know I need to go. So if you look at the projects, on the website, we've already seeded it with specific projects in application, research, and technology. I think the research would probably be better suited to the smart technology COE, where you've got proper programs and do proper research and all of those type of things. But I think the application-related projects and even the technology stuff is very relevant. In terms of African problems, I've got them listed in the red box. Poor education, skills development, poor healthcare, all of those type of stuff. So there's a bunch of stuff there. And you will see that some of the projects actually speaks to these kind of problems that we have. And I'm not going to go through detail here, but you can see some of the projects listed here. Application projects, financial inclusion, it's up there. So I've got a few financial inclusion stuff there. There's social network analysis, healthcare, and a bunch of other ones. And if you think, maybe we can talk about this in a panel discussion. And then on the research side, I've got some really interesting ideas of how we can improve the state of the art in machine intelligence, in artificial intelligence. And there's still a lot of breakthroughs that needs to happen to really take this to the next level. Deep learning is great, but there's going to be a lot better technology coming out soon as well. And there's opportunity for us to participate in that. And I've got some ideas listed there. It's also on the website. And then technology projects, Spark, TensorFlow, IBM Watson. There's so many stuff available. So this is awesome. Okay, I think I'm going to conclude with this. So back to you, Alex. Thanks.
Thank you, Jacques. That was a wonderful introduction. And please visit the Machine Intelligence Africa site for more information. And without further ado, I'm going to hand over to Gavin Marshall, who's our MC for tonight, and welcome our panelists up on stage. And to save time, I'm going to ask Gavin, I'm sure you're going to do a round of introductions with all the panelists. Okay. Great. Please take your seat.
Yeah, please come upstairs. I'll come onto the stage. How's it, everyone? So I need to watch very carefully that I don't swing on my chair, otherwise you're going to have some great YouTube footage for epic fails. There we go. Okay, cool. So I must admit, I feel a little bit out of my league here looking at all these people on stage. We have some super, super smart people, and I'm really, really excited to be hanging out with you. And so I would like you all just to introduce yourself. I mean, I know some of you guys for a while now, but if you could maybe just give everyone just an intro of who you are, as well as what really fascinates you about the space. And the other thing that I'm curious about is what got you interested in the space in the first place. I mean, I know when I was a kid, I used to make like these little robots and stuff with a tape recorder inside because I had this vision of this world where computers would speak to us and so on. And that's kind of, I know. She just said I was such a nerd. Okay, so I'm going to pass the mic. There's a mic over here. Why don't you pick it up if you want to make comments like that? All right, so... Yeah, it's working.
It's working.
Okay, so will you introduce yourself?
Yeah, I'm Jacques Ludik. I've been in this space of artificial intelligence for probably 25 plus years. So I've been there quite a few. Well, I'm counting out from university days as well. And interestingly enough, you mentioned where's the interest come from. So I was always interested in mathematics and computers. I got my first computer when I was standard 8, grade 10. But I was introduced to artificial intelligence probably my first year. I had some bursaries from from Institute of Maritime Technology, and we looked at pattern recognition, and it was Lisp and Prolog and all sorts of interesting. So it was those days, and it was quite interesting. So that got me interested, and then I did my honors, my master's, PhD, everything in neural nets and artificial intelligence, and lectured that for a number of years. Then started my first company, pretty much using artificial intelligence, software analytics company. And after that, it's, and even at university, I love to apply the stuff. So I remember working with, I was in computer science department, as senior lecturer there. I was working with chemical engineering, electronic engineering, the business school, about applications of artificial intelligence, and that was in the 90s. And then after that, I even collaborated with the Department of Psychiatry, and we've built neural network models of brain disorders, like obsessive compulsive disorder was one. And it was even a book that I co-authored and edited with Professor Dan Stein on that. It was just amazing stuff. And it just shows you there's so many applications, there's so many opportunities, so that's pretty exciting. But then Season Systems, I'm going to cut it short because Season Systems was 14 years, AI application, sold the company to General Electric. At GE, worked within this big data analytics industrial internet space for 4 years. Then at Jumo, data science, set up there. I was vice president in data science and chief data officer there for almost a year. Set up the data intelligence organization, worked on that. And I've set up some new companies, Cortex Logic and MIIA as well. So that's in short.
Sorry, quick question for Jacques.
Yeah.
You mentioned COE a couple of times in your,
Yeah.
and I actually missed what that was.
Center of Excellence.
Ah, got you. Okay, cool.
Brilliant.
Max.
Ah oui. Hi,
I'm
okay,
good.
so my goodness, thanks to my mum, I started playing with, I went to computer camp when I was 9 years old.
You're such a nerd.
Whatever. Well, part of my interest in AI was I discovered a book by Marvin Minsky. So one of the kind of grand super. Well, you know that Seymour Papert is South African.
Oh no.
Yeah. So Professor Seymour Papert of MIT, oddly enough, is South African. So there's lots in the field. Yeah, very good roots. I was fascinated by AI because awkward intelligence. I found it really uncomfortable being human, and I still do. And I think that I'm vaguely disgusted by the fact that I know I have cognitive biases. I understand. I mean, I teach. I help people dissolve the tech terror that they have. So I'm a lecturer, or have been for many years, owned a bunch of companies, and the breadth of my research is across a number of fields, but looking at where we can augment our intelligence with computers, with better thinking than we have natively. So this real quest for being able to find, how do I amplify my own intelligence or augment for yucky things like discrimination that we've got here? How do we use technology and artificial intelligence to strip back a lot of the stuff that makes us kind of awkward and weird and slightly evil as human beings? So yeah, I'm a hunter of genius. The genius that I'm looking for is maybe something elusive, but some of it, I think, is to be found in the collaboration of machines and really beautiful, amazing humanness, I believe that the machines can make us more human, not less.
Thanks, Max.
Hi, hello everyone. I'm Dishen Mudli. So now I have to reflect about why I got into this field in the first place. So it was probably in school, computers were quite, I guess I'm not that old, this was probably in 1986 or something. And I was playing around with the VIC-20s, Commodore 64s, for those old enough to remember those. And it was just fascinating that you could make these machines, you could program these machines to do weird and wonderful things. So that just hooked me. And then proceeded to study in the area and did a master's using neural networks in 1985. And then went off and got some industry experience in the US, in the UK, and worked for several companies. And then decided I wanted to come back and study further and completed a PhD in AI using ontologies and computer vision. And now I've just recently arrived in Cape Town, only on the 1st of July. And thank you. And I'm an associate professor in the computer science department at UCT. And we also, very topical, have co-founded with one of the other professors the Center for Artificial Intelligence Research. So this is not, I think, even government is taking this seriously. This is part of the ICT roadmap by the Department of Science and Technology. It involves 5 universities, and I think it's probably the most distributed network currently on the research side, the probably more theoretical research. I think I've said enough.
Nick.
Yeah, so I guess I also got into the whole field from a young age. You know, first computer at sort of 8 or 9 or 10, and grew up through school with them. Kind of actually veered off onto a very different path before finding my way back here. So I spent time in finance. So studied actuarial science and statistics essentially. But for my sins, spent a number of years in banking, chasing a paycheck, I guess. Yeah, as you do. No, I mean, there's a lot of interesting problems there, but to solve there. But certainly you can get sucked in quite easily, which I think is what happened to me. Broke free around the time of the crisis, which was a good time to jump out of that. And at that point, I was looking around for something to do. I wanted to get back to my technical roots. And that was a little bit before actually this massive big data craze and the resurgence of AI and machine learning. It's been around for a long time, but never more in the public eye than it is now. Around 2009, I went back and did a master's in London in machine learning and artificial intelligence. And then since then, I've been in the tech world, mostly in startups. More recently, one of the biggest companies in the world, working on essentially applied machine learning. So really taking all these algorithms and applying them to computational advertising. In London, we worked together at Mixit for a year, where I headed up the data science team and did a bit of work there on recommendations and machine learning. Co-founded a startup which was a recommendation engine as a service called GraphFlow. Worked on that for about 3 years, and more recently, unfortunately, that didn't work out from a commercial perspective. But more recently, I've joined IBM, and I'm working for them on Spark, so the Apache Spark project. I'm a committer on that project and project management committee member, and I work on that open source project full time for IBM. They've made a huge commitment to Spark as the operating system of analytics, and they're throwing hundreds of people and billions of dollars at it, and I'm one of those.
So cool. So I would like this to be kind of a conversation, and I know it's awkward with mics, so if at any point you want a mic, just grab it and interrupt, so we're going to have a bit of a brain jam rather than a question answers. And then you guys as well, we will include you a little bit later as well, and then so think of questions that you have and so on. So Nick, you mentioned that like suddenly now AI is in the limelight. What do you think is the reason for that?
Yeah, I think it's a really interesting question, because back when I chose to sort of jump into machine learning, it was starting to get there. It was a bit of a resurgence. it was occasionally popping up in, for those of us who follow startups, Hacker News and all of these, there were startups that were trying to start applying this technology. It was starting to come into the limelight a bit, but that was 2009 to 2010. It wasn't really the way it is now, as popular. So I think what's changed over the last few years is that, again, these methods have not always been there, but for a long time they've been around. So that there's two things that have changed, and one is data, and the other is computation.
Data in what sense?
So data, when people talk about AI these days, it's really machine intelligence, machine learning, statistics, effectively. Learning from data to try and predict the future. That's effectively what you're doing here. And to do that, you need data.
And volumes of data.
The more complex...
Yeah. Oh. Okay, I'm sorry. Yeah, no, I mean, a lot of that is the... No, man, flip, you weren't finished yet. I was just, I mean, the thing is that I was going to say it's just like the big data, having devices, having AWS, having consumer bits that we can play with as well has really changed it. It's moved it out of the realm of the big players to something that startups can tinker with, that it makes it a kind of plug-and-play space for us.
I mean, that's exactly right, and that's essentially what I was going to say.
Yeah.
The data in many ways has always been there. It's just that now we can collect it because storage costs have dropped with the internet and mobile devices. It's easier than ever to collect and store this data. And at the same time, the other side of the coin is that computation has caught up with many of these very complex models and the ability to store and process all of this data. Spark is just one of those, for example, technologies that enables that, but GPUs for deep learning and AI, the computation power in Moore's law has allowed the models to catch up with the data and to be able to be applied to the volume of data that we now have.
Production of data actually has increased manifold.
Absolutely. Just quickly want to comment on the data piece. If you think about the Internet of Things, we talk about 50 billion devices by 2020. So that's going to generate more data than us, 7 billion, 8 billion people, and in real time. So if you think about industrial internet, Industry 4.0, what's Siemens in Germany, well, it's tremendous, it's huge. I think the other piece in terms of data, if you think about dark data, unstructured data, videos. If you think about YouTube, you think about photos. A lot of data has been generated. I think probably 90% of the data has been generated over the last 2 years over the world, so it's actually increasing at a tremendous rate. But I think we do have the technologies now. If you think about deep learning, how it's been applied to unstructured data, and able to actually process that and get some insights from that. So it's structured data, unstructured data, dark data, it's Internet of Things sensor data, huge. So that's massive. The other thing that you mentioned was processing power. You work with Spark, GPUs, that is huge. It will make a massive difference.
Chips as well. I mean, so the NVIDIA... Yeah, sorry. That's you. But things like the NVIDIA chips, for example, that are particularly built for AI use. I mean, I think that
IBM Synapse, well, it's a bunch of NVIDIA, exactly. But GPU specifically, and there would be, so that's super exciting. I think there were some tweaks, improvements in terms of the techniques with Hinton and so forth. Well, you would know as well.
So we spoke a bit about top-down and bottom-up approach. Don't you want to just cover that?
Oh, okay. So I think trying to put a boundary of what is AI is asking, like, for example, what is computer science, and where does the boundaries of AI stop, and where does it merge or with computer science? And then there's is machine vision, is statistical analysis, is that AI? So there's all these. So there's one way, I guess, to kind of give probably a very basic split in terms of how AI developed. So originally, AI was not the statistical machine learning. Traditionally, it was the logic-based stuff. So it came from expert systems. Funnily enough, some of the AI systems, the original ones, where like 50, 60 years ago, well, probably 50 years ago, and it came from health. It was the mice and expert system, and that was with logic rules. And recently,
sorry, what does that mean?
Oh, okay, that's a good question. So it says logical basis. So to give you an example, if you have these, some of you probably did first year mathematics in propositional logic, where you have symbols. If A implies B and B implies C, and then you know that that B is true, then you can say that C is true. So all these rules, you have these symbols that are associated with concepts. You have these rules, and you can take, if you know something to be true, you can infer other higher level things to be true. So you can actually put these rules, if then else statements, if you want to call it, into these logical statements, and you can figure out what's going on. So that's kind of where expert systems came from. And then more recently, I think the focus has been on statistical machine learning. And this is using statistical analysis to, if you've got huge amounts of data, historically what you would do is you would build these models. So it'll take the past data, it'll build some kind of statistical model on it, and then when it sees this pattern again, it can kind of recognize that this thing has happened. So you use these statistical machine learning techniques to. Now, statistical machine learning is pretty much what we call bottom-up AI. So you move from the data, you learn models, and then you can predict. The problem with that is that when you make the predictions, it's based on patterns you've seen in the past. If the world is changing completely and there's new patterns emerging, you're in trouble. Then you have to probably retrain your models, etc., and there's techniques to look at it. The top-down AI, I'm taking very long now. The top-down AI is pretty much, we say that if we can go and take a domain expert and we can ask them all the rules they use. So a domain expert, for example, a scientist who sees, I don't know, a bee flying out in nature and makes a little note, and then they say, wow, I saw this bee, so that means this weather condition probably held or something is happening. And if you go and sit with them and you take all the rules they use when they see observations and how they make inferences of high-level events, you take all this domain knowledge, you put it into these rules, and that's called kind of top-down AI, which is expert knowledge. And really where we see where AI is going is if you be able to combine these two, and that we call, it's some of the work we're doing on cognitive systems. I think I'll stop there.
I actually want to ask you, sorry, I keep on switching this mic. There we go. I think it actually switches itself off because it definitely wasn't me. So one of the interview questions I would ask people when I was interviewing developers, and it's kind of crazy out there because I wanted to see, can developers be crazy out there? And so I'd ask them, do you think that the internet will ever develop a form of consciousness? And the one answer the one guy gave me, he didn't get the job, but I thought his answer was quite clever. He said, no, it'll never reach a form of sort of consciousness because we need to program it. And so it'll always be driven by programming, by logic. You know, and I think that's what you were saying. There's a certain sort of, I guess, messiness about humans, and there feels like there's a very sort of, like, you know, we're talking about statistical analysis. It just feels like it's just this one big super calculator, and never beyond that. And I think what you're talking about is, so Max, you're nodding your head. Dive in. What do you have to say about that? I'm stirring.
Well, okay. No, good stirring, because this is part of the reason why you don't need to be a technologist to really be intrigued and being able to get into the field of AI. You know, as much people who are anthropologists and philosophers, the issues around ethics, around security, all of these are because we're creating this meta mind of ourselves. But there are things like, for example, we're touching AI every day. You know, so if you use Siri on your phone, you're using a weak AI. So weak AI is just like a narrow focused AI. So there are the kind of artificial intelligence that the guys like Stephen Hawking freak out about is the superintelligence, where it will, you know, achieve that kind of sentient singularity, where it is well beyond the scope of, you know, of us being able to control it, where it's gone into this recursive self-improvement. But I think there's something about nature through, billions of years of achieving the weird wonder messiness that we are, it actually had very particular biological constraints that it needed to produce very self-interested creatures, which we are. And in creating AI, it doesn't need to be self-interested. But a lot of who programs the AI, what it's taught on, matters. The kind of fictions that it produces. It's again.
Definitely not me. I think the battery's running out. No, I'm good for now. Okay. Just want to get my train of thought back. Yes. So you Okay, so we had this conversation a while back around agent-based simulations, and I was doing this. I was reading around the sort of economic crash in 2008 and how economists didn't have the tools to be able to understand what was happening, because a lot of the tools they have were very sort of mechanistic and very, whereas now I think what we're getting to is a little bit more of that messiness that I was talking about, where yeah, don't you want to just chat a little bit about that, and then we can talk a little bit about cognition as well.
I mean, there is so much that's fascinating about the creative intelligence that's being produced as well, because there are comedy AIs, so actual comedians, robots, that are being produced, and as much as there are, so if you've ever, it's well worth going to Tiny Subversions. Darius Kazemi, he creates Twitter bots that have humor, that scrape stuff down, that create experiences of culture. But using bots, there is a sense of being able to replicate less of the technical thinking, because an artist may be a very mechanistic artist. A lot of art that's produced, actually, you can train an AI to paint in a pointillist style, impressionist style. But creating real creativity is the holy crap, where the hell did that thing come from? And a lot of that is just creating a little bit of an asymmetry, like stuff can come in from the left field.
Just quickly talking about that, what fascinates me, and I think a lot of the breakthroughs in artificial intelligence, machine intelligence, will be in unsupervised learning. The stuff that you saw with AlphaGo, they've been using deep reinforcement learning, so that's another very important area. But unsupervised learning is to a large extent still a mystery, and I'm not talking about the traditional stuff. It needs to be solved, so there's huge opportunities there. My PhD was focused on recurrent neural nets. There's a number of people, experts at universities that believe recurrent neural networks would be the ultimate unsupervised recurrent neural nets. That's what we're looking at. So a lot of breakthroughs that needs to happen. There's one interesting book that's I've got it also on the MIIA website, talking about future research directions in machine intelligence, and one was from I think it was Machines That Dream. And that is awesome. It's really unsupervised learning being utilized there. I do have a reference on the website to that as well, and we can talk about that as well. Anyway, yeah, talk about this. There's so many things.
So one of the things that, in terms of human-computer interaction, the interface that we use very often defines how we interface with something. And obviously with AI, that then gets super interesting, moving from filling in forms to chatting with the bot. One of the other questions, though, is if you take something like prediction and statistical learning, some of the stuff that you've been talking about, recommendation engines and so on, I was just thinking the other day, if we could build bots that could predict the stock market, I think that would totally screw up the stock market, because suddenly the behavior would change, because what we are by observing the system and by predicting the system, we're actually changing the outcomes of the system, because there are many different, and it's the same, for instance, with recommendation engines. Do I buy the stuff? Does the engine? I mean, how does the engine actually change my behavior in terms of I end up buying this because it's recommended that I'm buying this, or is it recommending it to me because this is stuff I'd like? Does it maybe change how the stuff that I would want to buy? So there's this kind of feedback loop between humans and machines, and I know we touched on it briefly around recommendation. Why don't you just maybe have a quick chat about that?
Sure. I mean, it's a problem not just in recommendations, but throughout any machine learning system that is making predictions in the real world. And as you said, it's part of a system, and there's a feedback loop. And if you're not careful as a practitioner, let's say you're actually coding these up and deploying these into a production environment that is interacting with humans and customers, you can get into this feedback loop. So part of the approach for this, I mean, it's a very active research area. It's not a solved problem per se, but I'll take the recommendation example. We all know that recommendations has come a long way. It's pretty good, but at the same time, even Amazon struggles to get it right. The biggest player in the world, and recommending stuff that you've just bought, for example, and all of this. And getting into that feedback loop of only recommending the things that you've most recently bought, or everything by the same author in a book. So one of the ways that you can do this is trying to actually actively inject serendipity into the system, and that can be as simple as instead of presenting the top 10 results, you mix them up a little bit. You inject a little bit of randomness into that system. And in that way, you don't always show the best result. You actually show a slight combination of that. Or that tends to, if you apply a purely, let's say, scientific mathematical approach to these models, you would end up with a worse result by doing that, according to your metric that you measure quality. That you use to measure quality, but in terms of real activity and real response from customers, for example, it ends up being much better. So there's some of these techniques that I think as practitioners and theorists we need to really think about. Another way is most recommendation models take what you like and say, okay, we're going to give you more of it. And I actually think that we had this conversation at Mixit. Was you could almost do the opposite. Take things that you really don't like. Find people who don't like those things, and then find things that they like and recommend those. So you actually turn the result on its head. You turn the whole mechanism on its head, and trying to find creative ways of using the same models, but in a different way, to inject that sort of serendipity, or that, as you said, that asymmetry, that chance for randomness.
So for guys who muck about with their algorithms, guys like OkCupid. And I don't know if Tinder does this in any way, but they had the ability to throw in people who were recommended who were clearly not in the usual sphere. And that suggestion, they were looking at the psychology, which is exactly why we need more people who have a little more interest in game theory. And this is just for all of us. I really think being able to figure out how we can be exploited by logic and by artificial systems, it's well worth us getting to know it. But I mean, I think one of the things that might be really useful for us is just how do entrepreneurs get into AI? Are there opportunities in it?
Cool. I have a mic again. So what are some of the opportunities? I mean, I know, for instance, I've been fascinated with electronics my whole life, but I've never really had the skill, or I mean, it took me like I don't know, most of my life to try and figure out what the hell a capacitor does. But then Arduino came out, and suddenly I could build robots and all that kind of thing. So what would be really cool is if there were those kind of building blocks within AI that anybody could actually just play with. And I think there are some of those. Do you guys want to maybe just mention some of that? You looked quite interested. Do you want to?
Okay, I think there's tons of opportunities. So maybe just to touch on a few. On the electronic side, I mean the first one is, I think, that's been around, especially in Africa, is drones. So these electronic, you can get a drone and you can go and fly about. But if you could do automatic monitoring, there's probably already ones, very expensive ones, have been deployed for rhino poaching, I think in Uganda or something. So it's if you could get the drone to get the imagery and to make sense of it automatically, and you could do a low-cost one, you'd have tremendous impact on farmers and huge any geospatial kind of thing. So we have drones, but if you could automate what the drone does, and you could really come up with some cool monitoring systems.
And autonomous, just being able to chatting about drones, the issues around you don't want a drone smashing into a tree. So a lot of these, autonomous sensors, that there is a company that you will know, Jacques, because I saw it on your site, is the Drone Deploy guys. And guys like Lychee who are doing software, third-party software that you can connect into your Phantom 4, whatever it is, and being able to play in that. So being able to create some kind of middleware around it to be able to allow people to tinker, but just roll up a chatbot. There are so many programs that we can play with. Get some Python on and tinker around with creating.
I mean, I was actually quite irritated by that when I saw Facebook come out with the not by you, but I mean, I spent 3 years trying to code chatbots. I mean, we coded some chatbots and mix it, and I mean, it took me months to get just the AIML and all the kind of stuff we're doing, and now you can just set one up and it works. And it's kind of irritating that the stuff that we spend so much time doing. But I think beyond that, I mean, take drones, for instance. You would have had to pay a helicopter pilot with a lot of skill, a lot of training to be able to take certain photographs. Now, anybody with the money to buy a drone at a lot less cost than a helicopter has access to that. Now, I dig it. And I dig the fact that we can create bots and so on. But what about the people that have those skills? And the jobs that these things are suddenly taking, the whole ethics around that, and I mean, do we just need to settle down and go, okay, well, the robots will do it for us? I mean, Uber is experimenting with self-driving cars. For me, that's just kind of, I don't know. What is your feeling on this industrial revolution that will potentially, make a lot of current skills sort of obsolete?
No, it's just topical for me because I can't remember whether it was on Twitter or even in a magazine, but I came across, interestingly enough, an IBM ad from way back. I mean, it must have been sort of late 90s or 80s or something, and it had a little anecdote that said, there's two men watching a mechanical bulldozer dig a hole, in a construction site, and the one turns to the other and says, if it wasn't for that machine, 10 people would be digging that hole and would have a job digging that hole. And the other turns and says, well, if it wasn't for your 10 people with shovels digging that hole, there would be 100 people with spoons digging that hole. So, the message there is that, do not be afraid of technology, because I think history has shown that, yes, it creates challenges, and this is true for AI, but it's true for all technology. But think about all the jobs that Uber has created, for example, already. The next step will open up higher level opportunities. The challenges, and I think you'll have a lot to say on this, is we need to ensure we don't get left behind as Africa and emerging markets, and where we know absolutely we have serious constraints, resources, education, all of these things. But I believe that the higher level opportunities will definitely be created. We should embrace that and make sure that we're ready to jump on that wave.
Quickly, just wanted to comment, first of all, on the previous question on the tools and stuff that's available. I know we also talked about it a little bit. I think a lot of what you would find, there's a lot of algorithms being bundled behind APIs and made available. So it's just yesterday I read about Loop AI, and they're actually using unsupervised learning. It's not, unlike IBM, it's actually completely unsupervised. You just feed it text, the API, the learning engine, and it actually has got a reasoning engine as well. So you just work with the learning engine API, the reasoning engine API, and it produces structured information for you at the end of that, and with evidence-based stuff. And you don't need to know anything about the underlying technology. So it's really, that's how far things are going. So absolutely, TensorFlow is a great abstraction. At the MIIA talk, we talked a little bit about TensorFlow and so forth. TensorFlow is great. If you think about IBM, IBM has got some great APIs. If you think about cognitive, easy to use. I've been playing around on Bluemix with a number of those APIs. The demos are brilliant, it's great. They are really awesome. So the opportunities are there. It's there. We've made it simple to use, so which is really awesome. I do have a slide on, maybe later on if it's relevant we can show that, but we talked about bots, but there are, I don't know if you know Shivan Zillis, she's from Bloomberg Beta, and she created this machine intelligence landscape. And if you look at, it's also on the MIIA website, and it shows you exactly the core platforms, the autonomous systems, all the different categories of, maybe it's worthwhile to show that as well, enterprise, and basically all the companies that's occupying those spaces. But what was interesting, she wrote an article on 8 categories, and she talked about a lot of companies, these companies are just focusing on focused data sets, which is like lasers. Then you get companies that's looking at broader data sets, she call it panopticons. Then you get gateways, magical ones. She's got 8 different categories for that. And it's quite interesting to look at that and see where you actually fit in. And it actually gives you some ideas in terms of companies that you want to start. Maybe this is where it would fit in there.
Okay, so I think it's probably time that I let you guys get involved in this conversation. I mean, I'm having a lot of fun, but we can't ignore you. Okay, so are there any people that have questions for the panel? Yes, okay, so please, I want you to stand up. I'm going to bring you the mic, and then it might stop working, because, yeah, okay.
Thank you. Nice to meet you. I'm Alessandro from Italy. I would like to know how IA will affect the warfare. And we will have more Ironmans, or we will have the less human involved in the fight?
Well, I mean, I was just saying I don't feel too qualified to talk about warfare. But I guess it raises a good point, is that, you know, it's easy to be, you know, as people who love this field, it's easy to be super positive about everything all the time and say, well, there'll be a, you know, net gain for humanity and everything's great, but definitely there's risks. And, you know, war is something that we'd like to see a lot less of. I guess the positive might be that, you know, as you mentioned, there might be fewer and fewer, you know, humans at risk. But it kind of, it starts getting to the point where...
Which humans?
No, exactly. It exacerbates the technological divide that already exists. So, you know, to answer the specific question, I think it's inevitable that you will see this kind of technology, just as you've seen all technology, be applied to warfare. But in terms of the... It currently is, yeah. In terms of the...
You've got the guys from RAND, for example. Sorry. I mean, you've got so much that's happening in terms of simulation at the moment, that you have deeply advanced warfare. So you have the US, for example, Alessandro, who have the deepest pockets. You know, they've got DARPA, they have all the brains they could want, still not being able to win against a very messy bunch of incredibly complex humans with, you know, with skills and a deep story and agenda. You know, so there is a humanness that we're dealing with here, that there's a clear delineation. And I mean, there's a sense of being able to get the intelligence augmentation, so AI, but certainly IA. What happens when you start being able to use genetic SNPs, you use CRISPR to create people who can, you know, run without getting tired. You know, you have people who can sustain, you know, the kind of strategic thinking that outdoes any other natural human. You know, where you've got implants. These kind of embeddable technologies are coming. So we are becoming as cyborgs as well. So IA, that intelligence augmentation, is a lot messier. Most of it is illegal because you can't test on humans at the moment, legally. But certainly in terms of warfare, I think it's going to be hardcore. I think there's going to be a lot of mess in between, and we cannot have the error of predictability. We cannot assume that there's a clear trajectory right now. We're up against a lot of very dark forces and a lot of humans who aren't all for intelligence, who are deeply anti-intellectual, and who are on that messy hatred, irrational side. So we do need to band together and make sure that we get the best brains in and augment our humanity in the best way possible, I think. It's my hunch.
I just want to quick small comment. Yeah, with great power comes great responsibility. And my problem is, I think with nuclear, if you think about, well, it's more difficult, but AI is going to be not that difficult to utilize. So we need to be super careful. That is true. I think with warfare, you would see, Alexandra, you would see precision warfare. You would be able to take out very specific, so you maybe cause less damage if you apply it properly. But in the hands of people that use it irresponsibly, it could be incredibly dangerous. And first robot killing, first open robot killing. Yeah. Texas. Yeah. Well, there you go. Yeah.
Sorry, you wanted to say something? So I'm going to be controversial, and I'm going to turn it totally on its head. So I think that warfare is going to change fundamentally, and not in the way you think it is. I think it's going to become electronic warfare. And what I mean by that is the world is going to move away from fighting over land and resources. It's going to be about financial. So, for example, there's always these rumors that the Chinese have an army of hackers who are fighting against the US, federal systems, etc. And really what you're going to see is that if people want to get control and power, they will probably, the easiest way to do it, if you're not just fanatic about it, is to go and write an algorithm which can predict the US stock market. Or write algorithms can do better hedge fund investments. Because then it's going to be about economy and money. So if you're using computers and AI, that's where it is. It's going to be virus attacks, information, predicting stock markets, hedge funds. That's where the power, and that's what people are going to fight about. That's the controversy.
Cool. I mean, it's a difficult question. I mean, you're welcome to sit down. Does that... Sorry? Sure thing. So I think what's interesting is also in our mythology. You know, when I say mythology, I mean like our movies and our stories. You know, there's always that underpinning of like not trusting the machines, or the machines actually deciding that getting rid of the humans is probably a good idea. You know, Age of Ultron and you know, the Matrix and so on. So I think that with our technological enthusiasm must always come a lot of really deep philosophical, ethical, you know, and we need to learn from our history. Sorry, can you all hear that?
Sorry. No, one of the things that I'm so sorry, I'm flipping it around, I want to ask you, because one of the incredible things that I think that we get with AI is the ability to change medical education, right? If you, instead of cramming for years all of the bits that can be looked up in a snap, yes, you need to do it, but what happens when you've got the sum of all knowledge, fantastic systems that can help with great diagnostics, with being able to give you predictive models and all the things that you would need? Would you become a better doctor if you had the chance to be able to have the spaciousness to figure out how, you know, like the human care around being a doctor? And could that education, would that change any time?
Yeah, so I'm specializing in eyes at Heidelberg, and we teach students there as well. And I'm just writing a blog saying why I won't have a job in 5 years' time. So that's at a very good time. And we developed an app that's collected a lot of photographs of people's eyes, skin conditions, broken bones, x-rays. And our app has seen 100 times more eyes than a graduate medical student. So I was actually going to ask you guys a question, how much data do we need to crunch? Because I thought it was millions of photographs. I don't think it's like 6,000 or 7,000. That's my first question. Medicine's going to change a lot. So I went to a presentation in London where a lot of robotic surgery was taking place. So I predicted in, say, 30 years' time, I'll chop off my arm and get something a bit steadier to operate. So I think, yeah, it's really going to, and I think the combination of human skill and machine kind of sort of, what do you call it, exactness, really, in medicine will really go a long way to help things. So sooner or later, if it's a picture of a skin condition, you'll get a response straight away from some sort of artificial intelligence rather than necessarily getting direct opinion. I liked your, what do you call it, when you get the domain leader or something? Yeah, I haven't heard that term before, but something like that where you combine the expert with the pictures and you develop something that's way more powerful than either human or the internet. But I think it'd be nice to see the combinations. I'm dying to chop off my arm, so yeah. So one question for the panel. Sorry, I know elections are coming up. If you put a DA bot, an ANC bot, and an EFF bot in the same committee, who would win?
Just to quickly answer your, well, not fully answer, but answer a little bit your question about the amount of data. It's true that generally speaking, you know, you always hear that you need millions and millions of data points to kind of do that. But there's been some recent research where the algorithm can learn to differentiate cats and dogs with as little as 100 images, for example. So I think that the theory, I mean, we talk a lot about data catching up and computation catching up, but you mentioned, Jacques, that the theory is also getting there where, you know, we can do a lot more with less.
Okay, we'll take the final question at the back.
My name's Charles. Quick question about global and local inequality and what you think AI might contribute or improve in that situation.
Do you want to?
There's many answers to that. One of the things that we were looking at, so even though I'm passionate about AI, I'm also passionate about improving our country and the African continent. So we spent a lot of time on the health side. So we've done quite a bit of research, and the research focus, and we got some funding from some philanthropic organizations, and the whole point they want is how can we improve health outcomes or decrease or health equity, because a poorer person from a disadvantaged community would get a poorer healthcare service or might not have access. And there's so many avenues that we can take. So for example, on just that side, to give you concrete examples, if you have HIV resistance, one of the things they do is a genotype test. And that's very expensive, and in low resource settings, it's not possible to do genetic testing for you. So we threw some AI algorithms at clinical records, and we were able to come up with a reasonable, at least to identify those patients at risk of developing HIV drug resistance without the genetic test. So then what we were able to say is in these areas, there's maybe 10 people that the government can afford to go for genetic testing. We can find the ones most at risk and send them. So that's an example. Another avenue we're doing, which is absolutely blue sky, is this whole idea of social injustice, and from the philosophical side, it's called epistemic injustice. And again, it's a little bit philosophical, and I don't know whether in the next 5 years we make any inroads into this, is because of the background, and either it's the education, we have a very Western education system, we're fortunate, most of us, to have gone through the system, and we can interact, hopefully, with some physicians and understand what they are saying. But someone who doesn't have that background, when they go and speak to a doctor or a service provider, they kind of access that, and they might even be community health workers, etc., which just take these medicines and not explain it. So we were looking at this kind of philosophy and logic rules to try and find out how we can get tools to identify what is the nature of those inequalities. What kind of knowledge or what kind of interventions do we need to bridge the gap between these two worlds? And you can use some of the deep AI or the logic-based stuff to analyze that and to explore that. Okay, I've said quite a bit.
Cool. So it looks like we've kind of run out of time. I've had so much fun. I mean, I could probably spend the rest of the night talking with you guys. So thank you so much for being here, and thank you so much for being here. I think if we can give the panel just a round of applause.
Thank you.
Right, thank you very, very much. It was some of the stuff going totally over my head, but it's really great to have you guys here. Thank you so much for taking the time to come as well. And thank you so much for all the support. So we want to say a massive thanks to, obviously, our sponsors, and a very huge big thank you to FNB. They've been incredibly supportive of us. And they've also, supported the entire ecosystem. So they help out with SIMA-DISA and Endeavour and the FNB Innovation Awards, etc. And then obviously massive help and support to Silicon Cape. So also want to thank you very much, Jacques and Max and Dinesh, Gavin, Nick, guys, thank you very much. And also to managing Gavin to being the MC, you're very good. We're going to have you back soon in the future. But yeah, thank you very much, everybody. Thank you to the Silicon Cape Exco as well, especially to Alex, who unfortunately had to run out, a medical emergency, and Toko and Tumi, that's really helped put this thing together. So thank you very much. There is still drinks and stuff at the back there. Do enjoy the evening, and thank you, and see you guys next month for an awesome event. Thank you. Bye.